Students and viewers, in this video, we will learn how to do animations of a 2 degree of freedom system as can be currently seen on the screen with GeoGebra application. Here, as you can observe, there are two independent objects or lines or points or vectors rotating independently. For example, point P or the line segment OP or the vector OP is rotating about the fixed point O with some angular speed, and point Q or the vector PQ or the line segment PQ is rotating about the moving point P with a different angular speed. For demonstrating this, we will first describe the locations of point P and Q, and then we will show how to do the animations. Here we will use the concept of position vector for describing as well as doing the animations. Now let us first draw the diagram manually. Here you can see a two-dimensional coordinate system that I have drawn. The origin of the coordinate system is at O. Now let us define the point P. Let us consider the point P is situated at a location where the distance OP is, say, A, and the angle made by the line segment OP is theta measured from the positive x direction in the counterclockwise direction. So, we can define the location of point P in terms of its coordinates as A cos theta, A sin theta. Now, let us consider a different point Q, which is situated at a location such that its distance measured from point P is B units and the angle made by the line segment PQ is phi as measured from the positive x direction in the counterclockwise way. Now, we will define the location Q in terms of the location P as can be seen here. So here, as you can see, I have written Q is defined in terms of P. So P plus B cos phi, B sin phi. So here I have defined the position of Q relative to the position vector in terms of P. So as you can see that the vector OQ is equal to vector OP plus vector PQ. As you can see that I have written the corresponding components along the x direction and y direction. So here Q is written in terms of P. So P plus B cos phi, B sin phi. So this second part on the right hand side is the position vector of Q relative to the point P. So here I have written that is OQ is the position vector of point Q, OP is the position vector of point P, and PQ is the position vector of point Q relative to point P. So these vectors and their corresponding components can be seen on the diagram. Now we will go for incorporating these in the GeoGebra application to do the animations. Now we have opened the GeoGebra application here. Now we will open the grid so that we can see clearly major and minor grid lines we will open, and then we will open the algebra view. Now what we will do, I have already written here so that it will take less time. Now for this case we will assume that the lengths, that is A and B, will be constant and the angles theta and phi will basically change. So as you already know how to set these parameters in the GeoGebra, so I have already written it for making it convenient or for making it faster. So as you can see that I have defined A is equal to 10 units, B is equal to 5 units. Now I have defined theta is equal to 1 degree. As you know how to do it, you can just open the keyboard or keypad and then set the corresponding parameters in the algebra view. So here you can just set a particular parameter, say for example A or B or theta or phi, and then set the corresponding values. so that I am not repeating in this video. You can see how to do that in the earlier video on lesson 1. Now you see that I have set the values of theta and phi as 1 degree to initialize that. Now I have defined point O, that is 0, 0. Here as you can see 0, 0. So that is point O, that is the origin of the coordinate system. Now I have defined point P, that is A cos theta comma A sin theta. So it is here as you can see. Now I have defined the vector U. Now I will discuss on this vector. So vector actually is a different command that I am using in this video. In the last video, I had used the segment command. Now so that you can learn a new function, I am using vector here. So vector will actually require two arguments. The vector function will require two arguments. So these two arguments are basically 2 points, that is starting point of the vector and the end point of the vector. So I have given for this OP vector, O is the starting point and P is the end point. So you can see the vector OP on the screen. Now I have defined point Q as I have described in the equations. So you can see the vector, the point Q is defined in terms of point P. So Q is P plus B cos phi comma B sin phi. As you have to observe that this is the basis for the 2 degree of freedom system, or the animation of two different objects with two different angles. So I have defined P in terms of theta and defined Q in terms of the location relative to point P. So relative to point P, there is the second part, that is B cos phi and B sin phi. So this phi will be used for the second rotation independent to the angle theta. So we have set two different angles and we will rotate them independently. Now, in the same way, so you can see the point Q here, as I have set the values of theta and phi. This is the current location of Q. Now, if I draw the vector PQ in the same way, that is the starting point of the vector is P and the end point of the vector is Q. So the vector PQ, that is the vector V, can be seen here. So that is the vector PQ. Now we can set different. You can see now if I rotate, then you can see them. You can see the rotation. As if I want to, if I animate, then you can see the animations. So as you can see that I have set the sliders so that the angles are changing. But here one thing to observe is that both are having the same speed, that is 1x and 1x. That is why you can see that as if the system, that is OPQ, is appearing to be rotating like a rigid object. Since both are having the same speed, if I change the speed, then you will see that different rotations can be observed. Now you can see that they are no more appearing to be rigid object. So we can change the speeds and see them rotating differently. One thing that I will do here along with this, that I will first pause the animation, then I will show you another feature which can be obtained from here, that is selecting beside this point P and Q. So that setting I can see, and then from here I can just check the show trace. For Q also I can do the same thing, show trace, or you can do it from point Q itself just by clicking on this and then clicking on the three dots, show trace you can select, or you can simply right click on this and show trace you can select. So by any of the three methods you can just select the show trace option. Now you see what happens. So the locations or the locus of point P or the trajectory of point P and Q can be seen. Now, to have clear understanding of the trajectories of these 2 points differently, I will set different colors for this. So for point P, I will set a color. So for example, I will set a color, say from here. So it will be blue, say. So now I will select the color or set the color for Q in the same way, color. So I will set, say, red. So point Q is red. Now you can see, if I animate, you will see it. They can be seen to rotate. You can set colors for the vectors also. So we can set the colors. So here for the vector PQ, I can set a color. Say for example, the same color, say blue. And for this PQ, I can set a different color, say for example, red. So you can see this. Now, if we animate, then you can see. Now, as you can see, these two rotating. So, as I have said, 1x for theta and 2x for phi. So you can see a particular curve is being produced. If you set different speeds, then you will see different curves or trajectories or combination of trajectories. In a future video, I shall explain and analyze these kind of geometries produced by different speeds. So as you can see that it is producing a nice pattern. Now another thing that I will show you in this video, that how to set the thickness of these vectors. So simply I will click on the vector and then you can select from here either. So thickness can be changed. As you can see, the thickness of the vector can be changed. So you can see the rotations. In this video, we have seen how to do animations of a 2 degree of freedom system using GeoGebra application. I hope that you have understood the process and enjoyed the video, and I hope that you can do it yourself. Thank you for watching, and I will see you in the next video.